Greetings everyone, Society 2, and today I want to talk about more of my theories of the universe and how it works, because I've been coming up with some crazy stuff that apparently other people have already thought of. So, I've been watching that show, The Three Body Problem, based on the Cixin Liu books, but I've also, before that even, I was thinking about the shape of the universe, which I tend to do a lot, because I previously made a video about how the sun works, how it's like a bowl of chili with crackers on top because the mass holds all the gas from exploding. I don't even know if that's true. Maybe I was wrong about that. But there's this thing about the cyclical universe theory. Either there's like the Big Bang, or the Big Bang could either turn into like a big freeze or the big crunch. Like everything gets so far apart that everything is too cold, there's no heat to keep the universe alive or keep it moving, so everything freezes, or that everything comes back together and just crunches, or the big rip, which everything just rips apart and then the fabric of the universe is torn, or something like that. Oh, I was listening to a podcast about I think Lawrence Krauss. They were talking about how he talks about how nothing isn't really nothing if you take like a certain amount of space-time, you take all the stuff out of it, you take all the matter and the energy and the quarks and all the subatomic particles and the radiation and anything that could possibly be anything. It's still a fabric. It's still bendable because of the way gravity warps around heavy objects in space like the stars. So even when you have nothing, you still have something. It's a substance. Oh, yeah, they were talking about zero-point energy, which is like a thing they mentioned in Stargate. I always imagine zero-point energy is like you have some kind of crystalline matrix that you poke a hole from our multiverse into another multiverse, into a place where there's a sun, and the energy from that sun comes through a pinhole like the size of an electron or something. So you're constantly getting energy into this matrix that can store the energy so you can use it for later use or something. But apparently they said, like, in a cup full of empty space, there's enough energy to boil the oceans off of the Earth. Just from being a substance. I don't even know how you would get that energy out. Because there's not like an atom that you can, like, split the atom and get the energy out like we do with fission. So, I think that got me started thinking about how the universe always existed, in my belief. And I think it's a cyclical universe where it stretches out and it comes back and explodes the other way, and it stretches back, it crunches back in and stretches back out, like this picture here. So I was thinking about that, and how this is really just a small cross section of what could be a donut shape, like a torus. So then I looked it up to see if somebody had already thought of that, and of course they did. And this is a toroidal universe kind of a thing. It's basically like this. So, if you look at where we are now, we theorized that in the center of this, call it a donut, with the center of the donut not having a hole like a normal donut. The center is a singularity, basically a size 0 point, where everything comes out of it, and then it goes around, and it comes back underneath, and it folds in on itself. So, does that mean that there's something outside of this donut? I don't know. Does that mean there's other universes that are similarly shaped like donuts that are all like crossing in between each other in certain places? Maybe they touch, they overlap. I don't know. But if you think about, since we look backwards in time and we see the Big Bang and we say the universe is expanding, that means we must be in the upper part. You can't see my mouse on this screen. But the top part of this donut where it's still like the funnel is getting bigger like this. So we must be in this part. And if you call the part of the universe we can see, the farthest we can see in a big sphere around us, call that our locality. Because the universe is bigger than what we can just see. So we would probably be like really small on this size scale, like a marble-sized little dot in there. And we think the universe is expanding because we don't see the part that's going back around and folding back in on itself. So if you're down on the bottom part of this donut, if you're a planet that exists down there, then you would see the universe is shrinking, and you're probably freaking out because Well, it'd still be billions and billions of years, but you're seeing the universe going back together, and you're thinking, well, what's going to happen when we all get closer together and everything starts smushing? Everything's going to get hot and dense, and it's going to start exploding. It's going to be real bad, I imagine. Equally, like for us, it's pretty scary that everything's expanding. It looks like everything's going to just rip apart or freeze. But yeah, then you got to wonder, like, if wormholes or like black holes are connected to other points in space on this donut, where does that put them at? Like, how does that work? Where do they go? How does it all fit together? Can you actually bend space-time like the way we think spaceships move? And if it's going to affect this whole shape. So the other thing I was thinking about is how, people always, like Christians, basically ask how, like, everything was created, like where did everything come from, how did it all like sort itself together. You think about how the earth spins around constantly, right? If you think about like a gold pan, when you have like some dirt with gold in it, you spin it around, you slosh it around, eventually it sorts itself. Heavier things go to the center and lighter things fall off and they disappear. And while that's happening on earth on a macro level, I think on a micro level you have a thing with cymatics. This is cymatics. This is the science of studying how sound waves, you can like use it to make shapes with sand or small particles to show like different frequencies of sound can organize things into different shapes. So if you think about that, I just had this theory today. What is the difference between light and sound? They're all just frequencies of energy, right? Obviously, sound is slower than light, so it's a lower frequency because we have planes that can break the sound barrier, but we don't have anything that go fast as sound or as light, because light's what we consider the upper limit of physics, like the fastest you can move. So, is light and sound the same thing? Which is kind of weird because in the Bible it says God says, "Let there be light," right? Like well, it also says He spoke the world into existence. Yeah, if the world is made of light and He says, "Let there be light," is that speaking it into existence? Or is saying speaking it into existence, is that just a code for like the universe was created by sounds? So that made me think, like, is it that atoms and molecules, maybe just atoms, maybe not even atoms, let's talk about sub-quarks, like whatever's smaller than a quark maybe. Like, cymatics affects things that are really small, so the smaller it is, the more it can be affected by sound. And just like light, we only have visible light range, like on the spectrum of light. Like we got microwaves that are like smaller frequencies, and you got radio waves, which also radio waves, that's sound, right? Isn't that a part of light? Sound and light, same fucking thing. So, in between there, we've got the visible spectrum. So, does that mean that the ability of us to hear things is also like a spectrum? And then there's way more, like there's subaural and superaural, I don't know what you would call it, like frequencies of sound that are higher and lower than our audio range that we can hear. Obviously there are, because bats emit high frequency sounds. So anyway, what if the universe is really fucking loud? Like there's just, well, maybe not, let's say noise, but maybe some kind of music or some kind of like frequency of sounds that causes the smallest particles to form into shapes like this and makes them stick together because they fit together like puzzle pieces, or the vibrations themselves cause them to interlock. This could explain how the pyramids were built if aliens were using it, or some kind of advanced civilization were using sound to like move things, which takes me back to this video here. And let me just adjust this. This is a spinning a magnet with a drill causes the other thing to levitate. So if you think of a magnetic field, this is kind of like how the planets chase the sun around, because it wants to come towards the drill because of magnetism, but also it's spinning so fast that it repels each other because of bipolarity of it. Pretty crazy. What's this one here? See, he's like levitating this thing. It's the same way that cymatics work. You can like levitate things with sound the same way. So sound waves and magnetic fields are very similar, I feel like. So that made me think, starting to lose track of what I'm thinking about. Yeah, the pyramids, like levitating the brick, or maybe just forming the whole thing all in one whole piece, like cutting away everything that's not the pyramid, or using maybe the pyramid was like some kind of resonant chamber that the Egyptians found later and they turned it into something else or something. But what was my main point going to be with this? I'm starting to lose it. The universe is a donut. Sound waves. Oh, let's get into the three-body problem. Let's watch this Neil deGrasse Tyson video where he's explaining the three-body problem real quick.
It turns out the orbits of a three-body problem are mathematically chaotic.
Yes, I was about to say, that did not seem very stable.
Something has to give.
Well, this is in the series. What we're talking about.
I haven't seen the series.
I know.
I'm just saying something has to give.
That's all.
Two of these are going to collide.
Right.
One is going to get ejected.
Right.
This is very interesting here. If you got three bodies of similar mass, this is why we don't include like the Earth, Moon, Sun system as a three-body problem, because they're all different masses completely. Like the Earth and the Moon are way smaller than the Sun. But the Sun and Jupiter and another sun could all be a three-body problem. And this says like whenever you do the computations on it, on a lot of the situations, one of the things gets ejected out because it gets shot off opposite the direction the others are going, so their gravity doesn't pull on each other anymore. It has escape velocity, basically. So it seems like with our 9 planets and all the different moons that we have, we're in like a 10-body problem, even though we're all like, most of these planets in our solar system are smaller than the sun. It wouldn't really pull on each other as much. But like over time, when our orbits keep getting close to each other and we keep pulling on each other, it seems like that would fuck things up. Like the way Christians are always talking about the fine-tuning argument, how everything was just fine-tuned for our existence. It does seem that way until you look at this math. I mean, everything's going to get fucked up eventually. Which is why I had that weird dream that one time. Remember I had that dream where the Earth started spinning like the McTwist, how skateboarders do the McTwist. That was like, it fell off of its axis or something and everything. The seasons all started changing weird. That was like crazy dream number 11 or something I had. This stuff really scares me. Not that I'm going to live long enough to experience any of these downsides, but...
Okay. That is the classical three-body problem. Three objects of approximately similar mass trying to maintain a stable orbit. And it goes...
So the three-body problem TV show is about this virtual reality thing where these people get into this game and they're trying to like save this alien species that's on its way to Earth because they couldn't solve their own three-body problem because I guess they had 3 suns and their planet was like spinning around one and then the other one would pull on it and it would go around this one, and then they'd have these eras of chaos, like chaotic eras and stable eras where you could have civilization build up and then everything gets destroyed. And then it would go stable again, and then eventually things would evolve and they would build up a civilization again, and then all of a sudden, chaotic era. They'd either get burned to death, or they would have floods, or everything would freeze, or the 3 suns would line up and the gravity would just suck everybody off the planet because 3 suns like focusing all their gravity on the planet. Like, that doesn't even make sense. When they're all like eclipsing each other, wouldn't all the suns get pulled together too? I don't know. That seems weird. It's hard to visualize some of these things. So anyway, my thing, the whole point of this video I was thinking about, in order to solve the three-body problem, I thought it might be that when the scientists or the calculus people are doing their calculations on which the masses of these 3 objects coming around each other, they're not considering the magnetic field of the suns or the planets. Because if you take the whole thing, let's go back to the thing about the torus, right? Yes, this picture right here. Let's see. This shows how things in life. Make that bigger. It talks about like tomatoes and oranges. God damn it. Stretch. See how everything in life, kind of the trees and the root systems are kind of like a torus. The magnetic field of the Earth is a torus. The galaxy itself kind of is a torus. I mean, that's kind of like a flat plane. Cell division looks like a torus. The human body with your arms and legs spread out is kind of like torus shaped. But the tomato and the orange, if you really think about that, like, yeah, if you take an apple, it fucking blows my mind because Newton discovered gravity because an apple fell on his head. And some books will say, like, the fruit from Garden of Eden was an apple that Eve ate, and that was like the knowledge of good and evil. And an apple has that funnel on the top, right? It's just like a freaking torus. It's like a donut. But the center, the core of the apple, or this is a tomato actually, the center, if you're like on a planet that didn't get shot out like the top of the funnel, like you went towards the little narrow strip right in the center, it wouldn't appear like the universe is really expanding to you. And it seems like if you're not, like, look at this picture here maybe, like in the center of that, you're not going, it's like your universe would collapse way faster than a planet that's on the outer skin of this donut. Like, is the donut solid? Is it, like, there has to be a thickness to it because galaxies are different. They're all like skewed different directions. Like, they're not all spinning on the same plane. So this layer, it's like a balloon that's filled up with gas, and the inside is it empty or what's in there? This shit blows my mind trying to think about it. Like, sometimes, like, how thick is the skin of this balloon that we're all going around? Because obviously it has to be at least as thick as a solar system or a galaxy. Like, what's bigger than a galaxy? Nothing. One of those clusters of gas or something. Yeah, and what are those clusters of gas? Like the pillars of creation or whatever it's called. Like, what the fuck? What is that? It's gas that just hasn't condensed into a star. And shouldn't they all be in the same direction if the beginning of the shooting everything out of the Big Bang was like when you had the more primordial star stuff that hasn't condensed into stars? It should all still be there, right? Of course, if we see it, we're looking backwards in time, and it may have already condensed into a star by the time, like by now. Maybe everything's a star now, but we still see stuff that hasn't condensed. By the time the light reaches us, this is the whole relativity thing. You have to think about that. Like, we're looking through time. So whenever you're looking at something in space, it's not really what's actually there. So how do you, like, even like in the TV show, Three Body Problem, right? This Chinese woman, she's aiming the satellite dish at the sun because the sun is going to amplify the signal so the aliens will receive the signal. So you have to, if you calculate the speed of transmission of sound, right, or radio waves, whatever she's shooting out of this satellite. I thought satellites received. I didn't know they transmit. I guess the thing in the center transmit and the dish receives. I don't know. Wouldn't you have to, like, lead your shot? Like, you have to figure out where the sun's going to be by the time the radio waves reach it? You wouldn't aim it directly at what you see, or would you? Because you're seeing light and you're shooting sound, and sound is slower than light. So it's like 7-minute transmission of light from the sun to the earth. But it's probably going to be like 15 minutes, or maybe like an hour or something for the sound or the radio waves to reach the sun. So you'd have to aim it like ahead of where the sun's right now, so it would hit it, right? You can't just aim across there at the sun. You'd miss it because it would shoot past by the time the radio waves got there. This kind of shit blows my mind. There's too many variables. It's like Three Body Problem. It's too many variables for me to compute. But the TV show, it's amazing. I really need to read the other 2 books now because I just really don't have time. I got too many other books. It's so sick the way they have these armies standing in formation and they're flipping signs because it's like a 1 and a 0 in a computer, and the computer has these whole like 13 million man army in Mongolia or something like that. Yeah, Yeah, and then they all like returns back with black signals. I thought that meant that they couldn't compute, but it turns out they were trying to figure out when the next stable era would be. So these people on this planet, they dehydrate their population and then rehydrate them in the water. Like, it's so weird and esoteric. I kind of forgot about that when I read the book, but now I remember that. I felt like when I read the book, it wasn't very interesting because there wasn't a main character. They kept talking about civilizations altogether as like a character or something. In the TV show, it's way more like you can follow it because you see the characters doing stuff. Anyway, does anybody have anything to say about this? Anybody agree with me that the universe is a donut? I was going to get like an actual donut that has, like, sometimes you'll get a chocolate donut and the middle is so full of chocolate that there's no middle, and I was going to like use it as an example, like the chili thing. It's like, this is the universe, but there's no... Or I could just get an orange and just show you the core of an orange, which I don't have any fruit right now. I just got an old banana in the fridge. Anyway, if anybody has any comments, I think I'm right, think I'm wrong about the cymatics thing, or the... If you use the whole planet's or the sun's gravitational field, then it's a way bigger mass, and like the air, you can see when the magnetic fields get closer to each other, then they're going to start interacting. If you use that calculus, I feel like maybe you'd maybe have the same problem. It would just be you would get closer before you lost the answer, and like things got weird. But I feel like if you take, I don't know, like everything, how far does the magnetic field go? Does it just keep going, like, weaker and weaker, and it's kind of like the whole... You know how, like, if you heat something up, it affects the electrons on the other side of the universe? Like, all the electrons have to move around and adjust for the shifting electron fields? I feel like magnetic fields are the same way. Like, the whole fabric of the universe, like, if it's like the Princess and the Peach thing. If, like, I'm sitting on one side of the bed and an ant falls on the other side of the bed, I'm not going to feel it, but it should send ripples through the sheets of the bed where, like, it affects the whole bed. Does that make sense? Like, even though it's not detectable, you should be able to compute it with calculus. I thought I've had like a better way to do calculus the other day. Because calculus is about, like, finding out the area of underneath a curve, right? Yeah. Think about this, boys. Here's a good example. Here I have a Ferrero Rocher box, right? If I had a marker, I don't really want to draw on this. Let's say I drew a line, like a curve on this, right? And I tell you to, like, figure out the area of this area underneath the curve. You would use calculus to do that, right? But if I said I can do it without, like, using calculus, what I would do is I would make a thickness to the graph, right? So now you have like a 1-inch thick volume of the same length and the width, right? And you put water in one side underneath the curve. You'd have to put it wherever, like, I don't know how you would do it, but you fill up the volume of underneath the curve, and you subtract that from the whole volume, and there you go. Just delete the thickness, right? No, you would get the percentage, right? So if I draw a curve like this, like it's a weird shape, right? Just a weird shape through this thing, and I want to know the area underneath this weird shape. I would just fill up the container with water underneath that shape, right? And I'll subtract that amount of water from the total amount of water in the whole shape. Now I have a percentage. So that if I want to get the area, I take the area of this rectangle and I subtract 43.657% or whatever that number is, and then I've got the area. The exact area, too. Calculus only gets you as close as you can possibly get because it uses rectangles that get smaller and smaller. This way, it's just like exact. So yeah, I just invented a better form of calculus and figured out the shape of the universe and figured out how the pyramids were built. You're welcome. You're welcome, YouTube.